All right. Let's take a look at the following problem. Here is a table, and there is a stick of mass m. It's held here with your hand, and suddenly you release, and the stick will then fall down and rotate with respect to the point B. And here I define the directions. X-axis, like that, and Y upwards. So the force here is a negative force in the Y direction. So the first question is, what is the torque with respect to the point B? And here is the torque equation, but from this point it's just 90 degrees with the force F. So it's just a multiplication here. And the force is negative. It equals minus mg. So this is the torque. And it's a negative number because it's in the negative c direction. If you rotate this stick, then it will be inwards in the direction. But the c direction is outwards. If you think about the cross product Ex, vector product Ex, Ey, then it will be outward. So the c is outward, but this rotation is inwards. So that's why you have a negative sign here. And we also have a law that torque equal the moment of inertia times the angular acceleration. So that is the task B. What is the angular acceleration? So it is this. But now the moment of inertia is not what we are used to. It's with respect to the center of mass, and that's ml squared divided by 12. But now we need to know the moment of inertia with respect to B. And one can use Steiner's theorem then. It says for a parallel axis, if you think about an axis directed outward here, and then parallel axis at B also directed outward. So for parallel axis, you have this fantastic rule that the GB equal the moment of inertia with respect to the center of mass plus a distance d, md squared, where d is the distance from the center of mass to the point B, which is L half. So therefore we can calculate this relatively easy. Here is the first moment of inertia, and here is md squared, but d is L half. So we will get this ml squared over 3. And we can now insert that in this equation here. And now you have the answer, angular acceleration. So that's B. And C, what is the vertical acceleration of the center of mass at this moment? So here's the center of mass. And as soon as you let your hand go, then the center of mass will start accelerating. Okay. So what do we know with respect to B? At least initially, the whole rod will make a circular motion, right? So this will circle, and also the center of mass will circle, at least for a very short time. So that's what I'm saying here. It will make a circular motion with respect to B. And then, of course, the velocity is just of the type omega r, for circular motion. And omega is the angular speed, and the radius in this case is L12. That's the distance to the center of mass. And we also realize that the velocity will be directed downwards, so it must be in the negative y direction. So, in fact, omega must be a negative number. And the acceleration is just to differentiate the velocity with respect to time. So you get this, omega dot. L, this doesn't change with time at the moment, or at near t equals 0. So it's omega dot. And omega dot is what? It is this. Omega dot is just angular acceleration, which we already calculated here. So insert it here, and here is the answer. That's the acceleration, and it's negative because it's directed downwards in the negative y direction. And D, find the vertical force at B. So, okay, the forces we have is gravitational force here, but you also have a normal force at B, right? And upwards until it can loose at a later point. So here's the table. Here's the normal force at this point, B. And there is a gravitational force downwards, and the acceleration is also downwards. Here's the y direction defined. And according to the center of mass law, it's the sum of the forces equal m times the acceleration in a certain direction, in this case in the y direction. So here are the sum of the forces. Fb is in positive y direction. Mg, which will be downwards here, is in negative y direction. And this should be mass times the acceleration of the center of mass. So Fb, move this over to this side. So that's the mg, and ag we just calculated and multiplied with the mass, and here you get the final answer, mg over 4. So when you held this with your hand, it was mg over 2 here, and also mg over 2 here. But at the moment you release, now you will get mg over 4 here instead. Okay, so the problem is solved. Thank you very much. Bye.